Okay, this is our first video on chapter 1. So in this video I'm gonna go over your chapter 1. However, I will not be able to cover every single case or examples covered in that chapter. I'm just gonna give you an overall idea summarizing the most important aspect in chapter 1. We're going to cover, this is the outline of this video, the data sources, population. So you will see some type of summary of what you learned in statistics. So you don't need to go back to your foundations in statistics. If you read the chapter, you should be able to remember most of the aspects that we will need in this course. One note that whenever you see optional in our book, is not optional, it's important. So this book is a starting of business data analytics, but it's an extension to statistical analysis. So the authors decided to have bigger population of students or faculty adopt their book. So that's why in my case I am more concerning using this book because of business analytics and data mining overlap with the statistic and not the other way around. So everything you see optional, 99% will be important and not the other way around. So let us start with data. So what is data? Data could be facts and figures from which conclusions can be drawn. One example, so let me go to, let's say I am using Google. Let's say I want to see a Facebook database. Who is using really Facebook? This is a good example. Okay, so this is the data collected by Facebook developers that tells us that we have different population using Facebook based on the age range and based on the gender. And as you can see in all the categories, the female use Facebook more than male. So this is the data that been charted in specific way. This is one example. So data can be, what we said, can be facts, in our case with Facebook, how many users we have by gender using Facebook. And we can draw a conclusion that our conclusion we found out in every category of age or range of specific age, female using Facebook are more than male. The data set is when you collect data and you have those variables and attributes. So in case of Facebook, in this case we have the age range and we have the gender. Those are the two attributes in this data. Gender in this case is category, categorical data, male and female. And the range here also is categorical because you have range. The first range between 13 to 17. The second range is between age 18 to 25, etc. So this is one way, and we're going to see much more data sets in this example, in this video. Third thing that is important, the variable that you are using to categorize your element. In the Facebook variable, first variable is a gender, male, female. The second variable is the age range. Here we go, a couple of some data set examples provided inside your textbook in chapter 1. The first data set is about the average basic cable rates in the US over 10 years since 1999 to 2009. So we have two variables here, the year, which is a number, represent the year, and then we have the cable rates, which is the average rate per that specific year. So we have two variables here. The one we are interested in called the response variable, and the other one will be called independent variable. And we're going to see those over and over in this semester. The second data case here is about a survey collected from customers about their opinion about a new design to a bottle. And also you can see detailed information about this case in your book. So as you can see, they give those people a form to select their opinion if they are strongly disagree with every comment or statement on the left side, or they strongly agree. Then what they did, they sum up the values of each customer and come up with specific number. Like the customer number 1, the sum up of all those variables were 34. Like in our case here, if this customer was unhappy at all, and put everything strongly disagreed, then you will have a value of 5 as his rating for this new bottle design. As you can see, numbers are high. And the highest will be 7 by 5, which will be 35. So we can see we got good numbers, so most likely the design of this bottle was good. So this is another type of data sets. Now, when we talk about data, we talk about the measurement, how we're going to measure those variables. And we have distinctive 2 types of measurement. Quantitative, which means they are number that can represent quantity, and qualitative, where we cannot have a number, actually we have category. Example for that is, in this case, what do we have here? We have number. In this case, we can say that the statement 1 has a value from 1 to 7. So those are categories. Category number 1, 2, 3, 4, 5, 6, 7. Yes, there is a difference between number 1 and 7, but this type of differences is categorical difference. What other example of category? Since we are watching the Olympic now, we have 3 categories of the medal. You have gold, silver, and bronze. Those are categorical values. Yes, you cannot distinguish between them, but you know that the gold is higher than the silver and higher than the bronze. But really, there is no meaning. That doesn't mean like the gold is 2 times better than the silver. There is no meaning, just there is an order, meaningful relationship. We also, in this book, notice that there is 2 different types of data selections. One of them called cross-section data, which is the time is not significant in this data. Example is this data I showed you from Facebook. There is no time mentioning in this data. They collected this data. They knew how many customers, female and male, are using the Facebook in specific time. And they reported the results. However, if you have time series data, the time is really important, as we saw in the first data set here. So you have the time series, so you can plot time series based on the years. Okay, so we have example. Here is a plot of that example. So you plotted on the horizontal line the years, and you plotted the basic coverage on the vertical line. And as you can see, with increased time, the average rate is increasing of the cable. So there is a type of relationship here. You can come up with a conclusion based on the chart, the time series chart you plotted. Now, data. From where we get the data? We have 2 types of data. Either existing resources that the government or from the internet, like the one I showed you, or Facebook, I got it from the internet. And there are very prestigious locations that you can get data from and come up with a research. One of them is the U.S. Census Bureau website, which is www.census.gov. This is a very important source for data because it really gives you an understanding in business if you want to come up with data related to some demographic information by regions in the United States. Another important resource of data for economics and financial data is the Federal Reserve, which is available on this link, and also the Bureau of Labor Statistics, also available from this link. So if you are conducting research for other type of classes, those are the three most reliable sites to get data from. Now, the other type of data, if you are running your own experiment, so you are collecting data. Let's say you send a survey on Facebook to collect information from your friends about specific product. That's observational type of a study. We have two types of studies. We can have experimental or observational studies. The experimental, this is the one very typical either in engineering or in medical field, where, for example, if a pharmaceutical company wants to test their new medicine, they select randomly a population. Half of them also selected randomly, they will give them that medication, and another half selected randomly, they will give them placebo, which is nothing. And then they will come up and study the result of the medication. So in this way, you have a full control on your control group that you want to give them the medication, and you didn't really assign this medication to them. Randomly, this medication was assigned to them. And you don't know what the result and who was whom. After you come up with the result, then you look at the who got it and who didn't get it. And now you can make up an honest legal judgment about the effect of your medication. However, most of the time, especially in business, we do observational studies. We don't have a control on our observations. We call, I mentioned that before, the response variable. This is the variable that you are interested in finding the value of. Like, for example, in Facebook here, you are looking for the usage. How many customers used the Facebook divided by gender. So here, this is your response variable. This is what you are trying to discover. However, the gender and the age range, those were independent variables. The one going to help you to identify them, to identify your response variable. So the factors, those could be anything related to those variables. In our case, was gender and age range. Now, how you can initiate a study? So first of all, if you come up with a research study and you need to know what you are interested in, this is what is called a response variable. In our case, Facebook, how many users are using Facebook? Then you're going to define the independent variables. In that case, we had one, the gender, and the second was the age range. And then you start doing your experiment, and experiment study, as I just told you, you have a control over your variable. If you cannot control your variables, then you will talk about observational study. And this is what most of the time in the business field, economics, finance, accounting, marketing, will be observational type of data analysis. Now, okay, we have data, so where are we going to put that data? There are many different types of data warehousing. So again, you can imagine maybe the RS data. There is a data warehouse where all the data is collected and saved and restored. What else? Maybe the Medicare data. There is a website connected to SQL servers where data being collected and added in that server. And you have been hearing recently a lot of buzz about the term big data, which is a massive amount of data. And that's what's happening now. You can see, we can tell how many users we have on Facebook. So let's go back here for a second. If you want to see how many users, so he's telling you in 2016 we reached about 1.65 billion monthly active users. So to be able to calculate that, most likely they have big data server that can really examine the amount of users using the server per second even, not only per month. Some of your previous statistic analysis background, you remember the population. This is where you want to apply your, you want to find something from your population and you want to draw conclusion about them. In Facebook, you have 1.3 billion customers and you want to draw a conclusion from them. Now, if you use all those 1.3 or whatever, let's say it's 2 billion, if you're going to use all those population, that means you are examining the census, what is called census data. You are using the whole population, which is really difficult in reality. But now with big data, those big companies like Google and Facebook and Yahoo, all of them are capable of doing such type of analysis. Now, when you cannot draw a conclusion about all your population, you take a sample, which is a subset of your population. Now, the measurement. We talked a little bit about the measurement. One example will be if you want to know the annual starting salary of all graduates from last year's MBA program. So this is what is called observations. You're looking at those observations and you're trying to draw a conclusion about all the MBA graduate salary, but you have a specific year, maybe Western Kentucky program only. So we call this a subset to analyze this salary range. Statistic in general is divided into two types, the descriptive statistic and statistical inference. This is what you learned in the past. So what is descriptive statistic? Is a science of describing the important aspect of a set of measurement. And we say the set because we are not using the whole population. The inference, on the other hand, is using a sample of measurement to make generalization about the important aspect of a population of measurement. Like we did here in Facebook, we could say that we noticed that in 2010 that there is more female using Facebook than male. That will be our inference on that study. Now, in your book, and please read those cases, you will have 3 cases to come up with the idea of sampling and statistical inference. Again, this is like just an overview from your past statistic, and we're going to see where business analytics is going to fit with statistics. First case was a cell phone case, how a company is trying to reduce cell phone costs. Imagine Western Kentucky, they wanted for all the employees, instead of giving them a plan of that they would pay $100 for each employee to use their phones. Instead of that, they hired some third party and they wanted to see what is the best package for their employees. To discover it, they needed maybe to get a simple set of those all Western Kentucky employees and apply their analysis on it. The second case, a marketing research case, the one we saw the data from, which is how people rating the new bottle design. The third one, car mileage, and it's another case which is will estimate the mileage of 50 cars available in this data. Now, so the first case, which is the cell phone case, we are considering using a company to manage so this is the idea. This company wants to manage their cellular resources. They randomly selected 100 employees that they were on 500 minute plan, and they looked at their overage and underage. So just to know how many minutes they use. As you can see, some of them they didn't use any of their minutes, 0, and some of them exceeded the 500, 654 for example, this specific employee. So that's one type of ways of sampling your data. The second example, the marketing research case of the new bottle design, what they did, actually they went to a mall and they tried to use something called mall intercept method. They're only going to pick 60 customers, and they're going to build their finding based on that sample size. they gave this form of rating. Was customer rated every statement from 1 to 7. They sum up the values, and this is their case, which is using a systematic sample of 60 shoppers. And you will read in your book why this specific case has some drawbacks about the way you choose your customers. Terms. What is process? The process is a sequence of operations that can take input and turn them into an output. So, example, we took the input of our customers from 1 to 7, and we turned them to a sum, and we are going to use this value as a rating value. The finite population, like example, my students in this course, I have 70 students attending the business data analytics course. This is a finite number of students. I can ask you to fill a survey, and I will tell you, if you don't fill the survey, you'll not get into test 1. So most likely all of you will fill the survey. However, the number of population is 60, so I'm using 70. I'm using all of you, so this is a census type of data, but the population is very small, so my conclusion will not be that accurate to consider. Infinite population, let's say United States citizens, this is a really big survey. To be able to do it, there is no way. So you'll have to find a way around it to come up with some conclusions. The second case we saw, the care mileage case, that will estimate the mileage. So they are trying to study the tax credit offered by the federal government for improving fuel economy. So if the new design of a car reached that specific number of mileage, this company with their car design is going to be offered a tax credit for the new design. So they have some type of 50 cars, and accordingly they're going to come up with a conclusion if they keep trying to estimate the mileage over time for each of those cars and see which one really maximize their mileage on that specific car. This is a sample of what you will see in your book. So they looked at those sampled 50 mileage, they plotted it over production shift, and you can see there is some infatuation between those numbers, but somehow it is the average of it is more than 30. So they really did well. It's almost 31. So statistical modeling. So now we talked about statistics. How about we are creating a model based on what we saw from this population? And this is something you learned in statistics. You learn normal distribution. You use the what is also called probability distribution of your population. So probability sampling, you sample where you know the chance that each element in the population will be included in the sample. For example, if you want to look at again the Facebook data, since you considered every range of age in your data, that means you included all the categories, and your assumption that the female use more male Facebook is not biased. You selected from every range of customers that really use the internet. You know, you cannot use it if you're younger than 13, and apparently there is not a lot of people older than 65 using the Facebook, at least in 2010. Maybe now you will see some more. There is something called convenience sampling, and here where you pick your elements. Like example, assume you send a survey to all your friends on Facebook. This is convenience sampling. You sample based on specific population, and if you want to judge a product design, so really you are biased in your sampling. Another type of non-probability sampling, voluntarily response sampling. So you self-select also This is bias frequently used in radio and television. So they make a poll, for example, the election, and you can see for sure that those people who watch that specific channel, they will rate, whereas the others, who doesn't watch maybe Fox News, they will not give their opinion. So the opinions at the end will be biased by their customers. Also, another one, judgment sampling. You make based on your experience and knowledge, you pick your sampling, which is also is biased because you are judging the sampling based on your personal opinion or expertise. Of course, there are ethical issues when you come up with conclusions and you are using improper sampling. Their conclusions are incorrect, and we're going to see that in chapter 2 in section 2.7. Sometimes they will maximize a chart where it shows bigger numbers and minimize it in other sections. We're going to see that in details. Now, which is really important section. This is one of the sections that I said it's important, but on your book it says optional, so please pay attention to read those sections. With the internet growth, we noted that business analytics and data mining started to take place in our life. Big data is being collected, and now not only we can analyze a small portion of data, but we can analyze a huge amount of data, and we can come up with conclusion from it. So if you want to differentiate between statistics that you learned in the past and business data analytics, the idea is the following. In the past, you had simple data, maximum 1,000 of elements, you come up with conclusion on it. However, now we have hundreds of thousands, millions, and billions of data points you want to come up with conclusion about. So the methods are different when you are working with business analytics. However, the statistical foundation is important because you'll understand why the statistic is not working now with big data. 3 distinctive parts of business analytics are descriptive analytics, predictive analytics, and prescriptive analytics. What is each one of them? The descriptive analytics is the use of traditional and newer graphics to represent easy to understand visual summary of up-to-minute data. Very similar to what I showed you with the Facebook data. Or let's say, let's go back here, this is some type of descriptive statistics. We are showing you the mileage rate over production shift, and we are looking at the mean, for example. So if you remember the means and the variation and the variance, those are the type of descriptive statistics that or analytics you can use, however with a bigger data. Predictive analytics, it's a method used to find anomalies, outliers, patterns, and association in data set to predict future outcomes. Now I'll give some examples when I go into each one of these. Data mining, it uses a predictive analytics, so as you can see, each one of them it builds on top of the previous one. Descriptive analytics is built on top of statistics. Predictive analytics is built on the descriptive analytics. However, it allows us to do much more things. Like anomalies is one of the examples of the fraud detection. You hear a lot of cases where someone take your identity and try to hack your bank account and take money from you, and how your bank is trying to prevent this from happening by looking at anomalies of your purchases. For example, if you live in Kentucky area and one day you purchased some item in California worth $1,000, that's an anomaly. Immediately your bank account will shut your access and will get rid of that anomaly from your data. We're going to see a lot of these examples during this semester. Now, the data mining is the use of predictive analytics algorithms and information system techniques to extract useful knowledge from huge amount of data. One example in Obama's campaign, They use data mining to know which are those voters. They have to go and personally knock on their door to get their votes. They knew it from this big, huge data and based on their previous behavior over the years. That's one example. The last one, the prescriptive analytics, will look at variables and constraints along with prediction from predictive analytics to recommend courses of action. As example, Amazon. If you go to Amazon and you started to purchase a book, they will give you a recommendation saying, who purchased that book also purchase the other book. This is type of prediction that, okay, we think he will be interested in the other element, and accordingly they give you the element and you might purchase it or not. So the application of predictive analytics, this is really important. Anomaly, I just gave you an example of credit, what they call it, risk analysis or fraud detection, anything that can detect outliers of behaviors. Terrorists, this is one type of outliers behavior, buying guns. When someone never bought gun in his entire life, then one day went and bought huge amount of guns, and that should trigger something in the system. We know that there's something happening. Number 2 is association learning. This is when you go to Walmart and they know that if you purchased milk and chocolate and rice, most likely you're going to purchase maybe butter, who knows. So this type of association in items, accordingly they will give you a coupon when you leave the store associated with whatever you purchased. Classification, this is where you classify maybe people or you classify products. Cluster detection, if you want to see similarity between customers. For example, Best Buy cluster their customers based on their salary, based on their purchase habits. So accordingly, they give different credit amount to their customers, especially the newer customers. Prediction, one of them is forecasting, the weather forecasting or the market forecasting, Wall Street forecasting. Factor detection, this is the one that tells you which one of the variables are the most important to help you predict what's going to happen in the future. There are 2 types of techniques in predictive analytics. One of them called supervised learning, which means we know what is our response variable, we know what we are trying to predict. Unsupervised learning, we don't know. You might heard in the past, and you work with linear regression, we're going to see some type of other type of modeling, and there's a supervised learning like logistic regression, neural network, and decision trees. As I said here, you know what you are looking for. For example, if you want in this data here, you want to know who were the I have also customer, the 60 shopper, and I want to divide them into all the customers who rated us between 6 and 7. This is my response value. All the customers rated us between 3 to 5, and all the customers who rated us 1 or 2. So this is like 3 different types of categories. That could be considered the case. Okay, so this is a supervised learning. We know what we are looking for. However, unsupervised learning, this is where we don't know. Like Best Buy, they have all those customers. How they're going to divide them into category, they don't know. They have to really look at all the variables. One of them may be their salary, if they own a house or not, if they own a car or not, what is their, how many siblings in that family. All those factors maybe together will cluster information of all the buyers into 5 different clusters. One cluster will be the profile people with salaries higher than 100,000. The second cluster may be those customers, their salary between 50 and 80, but they are single, etc. So this is the type of clustering we are talking about. Well, that's why it's called unsupervised, because you really don't know what the response is going to be. Now, which is something from your past, you learned about those. We say that the variable can have 2 types of variables, 2 types of measurement, quantitative and qualitative. We can divide them as following: nominative, ordinal, interval, and ratio. The nominative example is gender, car color. So there is no importance, like category with no importance. If your car is red, doesn't mean anything compared to black or white. The ordinal, where the also is categorical, however the order is important. I gave you the example of the medal. If you want the gold medal, is more important than silver, is more important than bronze, but that doesn't mean it's twice important or 3 times important. Or if you have a bronze, that doesn't mean it's not important. One example here is the teaching effectiveness. Interval variables, those are the variables that very similar to the ordinal. However, there is a 0. However, 0 doesn't mean absence or anything. It doesn't have any meaning. One example, so you don't forget it, is temperature. So 0 Fahrenheit means cold, not no heat. Okay, and 60 doesn't mean twice 30. So it is a number, however, it doesn't have meaning of the 0. And finally, the ratio, where the 0 has a meaning. And this is most of the business data, you will find them are a ratio type of variables. The 0 means no money in this case if I'm looking for a cost of something. Okay, and this is what we're going to use the most. Some example: earning, profit, loss, age, distance, height. This is what you can consider as a ratio variables. Now, how you sample your data? Beside the random sampling, there is something called stratified random sampling, or cluster and systematic sampling. Those are really good ways, and there are a couple of examples in your book. You need to read them. So when you sample, there is something called sampling design. Which type of sampling you're going to use? Randomly you're going to select, or you might divide your populations into some strata, and based on that you're going to decide. Like for example, again going back to the Facebook, if I want to pick random sampling of all those populations to do an experiment on, I may use random sampling of 10,000 customers from all this data randomly, or I can decide, like this is one strata, one category, the age between 13 to 17. I'm gonna pick, so I have, let's say 2, 3, 4, 5, 6. Let's say I'm gonna collect 6,000 customers. Instead of picking them randomly, I want 1,000 from this age category, 1,000 from the second age category, etc. So this is what is called. So each one of those is one strata, one group. So please read some examples. This is really important to understand. The second one is multi-stage cluster sampling. This is where you don't know your all population. They gave you example in the book about voters. If you want to know information about all the voters of the elections in USA, we don't have this data, but you can divide your data into clusters. So let us come up with all the states, then let's come up with one state, then let us come up with one county, or the capital, the county, and then we can reach the voters, and then we can randomly select from them. Systematic sampling, also this is like you select random starting point and you start sample each, maybe the 10th element of each one of them. Now, in general, when we look at any type of survey data, we can see this type of variables. You can see maybe a yes, no answer, gender, female, male. So the economist questions clearly stated, easy to answer, easy to analyze, limit information. Then you have the multiple type choice of questions. So they have more than one response. And then open-ended questions, this is where you put your input in text. And those are the most honest response, but they are the most difficult to analyze. But I should mention that with data mining, there is a complete field called text mining, allow you to take this text and analyze it. And this is what we see in other courses, data mining, I teach in business data analytics courses. So type of survey, you may have phone surveys, they are not expensive, but people, they don't like to respond. You might get lucky, but the response rate is very low. Mail surveys, web surveys, and personal interviews, which are the highest response, and you have more control and it's more expensive. Sometimes you have to give incentive to let people answer those surveys. Now, at the end of this chapter, there are plenty of terms. Please read them. I mentioned here some of them, but please pay attention to them. I'm going to add this PowerPoint I created here to your week 1, so you can look at it or print it out, and it should be handy. Okay, so what else? Yeah, I should mention here some of the terms. Selection bias, we talked about how you can be biased by selecting a specific population and not considering all population. Errors in observation, this is always can happen. Someone recorded the values wrong. Also, and response bias. So we talked about, and you can find more terms used in this chapter. That's it for now. I'm going to create another video related to Excel and how you can create a time series plot in Excel.